Hi everybody, welcome to a short video I'm calling Unconventional but Important Geo-Resources. And in this video we're going to look at two ways by which elements can become enriched that are pretty unique. And by this point you might be catching on that most mining and extraction of resources really involves first nature having somehow enriched an element that is valuable to humans. And nature's done a lot of the work for us, and we humans can then come along and extract this enriched element and then finish the purification ourselves. So nature's really helping us to enrich this stuff in the first place. So the first example we'll look at are laterite and bauxite soils, and then we'll look at evaporites. So laterite and bauxite soils are the main source of aluminum ore to the world and are also an important source of iron. And these are incredibly ancient soils that are formed in very old landscapes, places like Australia and Brazil, where literally soils have been forming on these landscapes for tens of millions of years. Okay? And now as these soils form, what happens is iron and aluminum become concentrated in them. And they become concentrated because they are very strong cations. They have +3 charges. And that's a higher, stronger electronegative charge than most other elements like potassium and sodium, which are +1, for example. Now, why is that a benefit? Well, it turns out that most soil particles, like humic particles, that's basically organic material, and clay minerals, are negatively charged. So these negatively charged particles make up most of soil, and they want to attract the positive aluminum and iron ions, and they do. And those aluminum and irons bond really strongly with the negative soil particles, and they don't let go. So what happens is over millions of years, the weaker cations end up getting leached out of the soil. They're flushed away by water, whereas the iron and aluminum become ultra concentrated and actually ultimately start to form things like iron oxides and aluminum oxides. And of course, it's those iron oxides that give laterite its very red color. And interestingly, those oxides also make it incredibly strong. Bauxite and laterite aren't really soils proper, they're really rocks. You can see this guy in Sri Lanka chopping up bricks of laterite, this incredibly old concentrated soil. So now let's take a quick look at evaporites. Evaporites are mineral deposits that form in closed lake basins by the evaporation of water. So these often are found in desert environments also, where evaporation is really intense. And what happens is that natural waters, rainwaters, fall on the surrounding mountains, okay? And that rainwater then goes into the ground and is ultimately channeled through the ground into these closed lake basins. And as it flows through the ground, it dissolves and leaches incompatible elements out of rocks. So for example, this might be things like lithium, which is an incompatible element. That lithium gets dissolved in the groundwater, and the groundwater ultimately discharges into the closed lake basin, bringing that lithium with it. But now what then happens is that the water evaporates right back out into the sky. But the lithium or other dissolved ions doesn't evaporate. It stays behind in the closed lake basin and becomes concentrated. Now, as those dissolved ions concentrate over time, the solution or the water reaches its saturation point, where it cannot hold any more dissolved element. At that point, crystals start to form, and these are often things like sulfates or carbonates or halides. So here's a few examples of these. One famous example is, of course, halite, which is common table salt. That's sodium chloride. but there's many examples of evaporite minerals that contain all different kinds of elements. Now, table salt, sodium chloride, believe it or not, actually comes from this exact process. A great example is Morton salt, which you may have had in your home, which is literally produced by evaporating very salty water from the Great Salt Lake in Utah. And then the water is evaporated, the salt is harvested, cleaned up a bit, and then distributed to you to make your food taste better. Another really important example of evaporite minerals is lithium evaporites. And these are found primarily in Chile and Bolivia, way up high on the flank of the Andes volcanic mountain range. And lithium here occurs in briny water and also in evaporite salts. And again, it's the same process where water over millions of years has leached lithium out of minerals like biotite and hornblende, which are common in the volcanic rocks of South America. It leaches lithium out of those minerals, carries it into these closed basins, and then creates these lithium minerals. One very common mineral is lithium carbonate. Shown here, looks kind of like a white salt, and is very, very easy to process to get pure lithium. Now, lithium is an important example because it is the main ingredient in lithium-ion batteries, which of course fuel our cell phones. They also fuel our electric vehicles. And as we move more towards, for example, electric vehicles, the demand for lithium is going through the roof. So that's evidenced by this chart of lithium carbonate cost per ton, which has more than doubled over the last year. So one of the interesting questions here is, will the supply of lithium carbonate be able to increase to match demand and ultimately reduce the cost of this resource? And of course, that's really a geological question. Are there enough evaporites? Are they pure enough? And can we access them to meet this global demand for lithium carbonate? So in summary, we've looked at laterite soils and evaporites, two very interesting ways to enrich elements that are economically valuable. I'll leave you with a concept question. There's no quiz for this video, and thanks for listening.